activities with them. Okay, see, they should not say that they don't have device or any problem they have to tell. You should interact with those students and identify them.
In the math class, we faced the same problem. So the math coordinator made phone calls to such students. So they will start taking classes, but they don't take classes now also.
So you see, the class test is going to start on from Thursday. You all know it. Okay. Yes. So they should respond to the teacher. So you make a list of those students, please, Ishank. You must be having the list, right?
Yes, I have the list of the students.
Yes, you please send me the list by WhatsApp. Then we have to. Then you start interacting with them. Thursday is a class test. They should respond to the class test. Okay. So if not, I mean, there will be some problems. So if they have to do it within the time frame, na? Okay, better. So you should inform them as a class representative. Fine. So how many of them joined? 68 have joined. So I will start the class. Okay, let me start recording. Let me record the attendance also.
Ma'am, now I have joined with my ID only.
Yeah, that is important, because if you are caught, I am not responsible for that. You will be caught.
Okay, sorry, ma'am.
So everything is getting recorded here. Okay, so I will keep recording after the class also. Now I am going to present. Okay. So can you see my screen?
Yes, ma'am.
Yes. Yes, ma'am.
So so iodometry. Have you understood this? Beta?
Ma'am, you have to start from here, iodometry and iodometry.
Iodimetry means iodine is used. Okay. It's a direct titration introducing substances with iodine. That is iodimetry. The iodine is used. Iodine is titrated with sodium thiosulfate. Reducing substances are directly titrated with iodine. This is a reducing substance. This is oxidizing. Okay. Here the indicator used is a starch. Is an indicator. Okay. Iodometry means iodine is released from iodide. Here potassium iodide is used. Using the potassium iodide, iodine is released. The released iodine is titrated with sodium thiosulfate. Okay, this is the difference between iodometry and iodometry. Got it?
Sorry, ma'am. One more time, repeat, please.
Iodometry. The iodine is directly used and titrated against sodium thiosulfate. Okay, so iodine, the reducing substances directly titrated with the iodine. This is a reducing substance. Okay, this thiosulfate. Okay, so in iodometry they use potassium iodide, excess amount. Okay, so iodine is getting released. Okay, and released iodine is going to titrate with sodium thiosulfate. Okay, this is the difference. Both the cases, starch will be used as an indicator. So this experiment you are going to do dissolved oxygen and dissolved chlorine. These are all two experiments you are going to do in the practical. Have you started this two experiment in practical, beta? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So these things I will also explain. Okay, let me give the preliminary things. The titrations are liberated iodine. So iodometry, liberated iodine from the sample is titrated with the reductant. It's the sodium thiosulfate. Okay, so these are all like some examples. Okay, any one of the examples you can remember. Okay, iodometry is a direct titration. Direct titration with sodium thiosulfate. These are all other examples. You can give the example of this one. Okay, this is the simple example you can give. The many examples have been given. Simple example you please remember. Okay. That is a difference between iodometry and iodometry. So before giving specific examples to the iodometry and iodometry, let me introduce the precipitation reaction. Okay, what is it? This is a fourth method. Precipitation titration involves what is happening here? You are taking one solution, that is primary standard in the burette and analyte in the conical flask. When you keep titrating, the precipitate formation will take place. Okay, that is called the titrations where the precipitation is taking place. Precipitation formation takes place. Those type of titrations are called precipitation titrations. Okay, or precipitation reactions. For example, the silver nitrate. Okay, silver nitrate is a primary standard. Okay, and sodium, of course, sodium chloride also a primary standard. Here, this will be taken in the burette. This is in the conical flask. When you titrate dropwise, when you add, mix this silver nitrate with the sodium chloride, there will be a precipitation of silver chloride, which is white in color. Okay, this is sparingly soluble salt. Okay, so sparingly soluble means it doesn't dissolve, it very slightly dissolves. Okay, that means that is a sparingly soluble salt. This type of titration is called precipitation titration. Got it? Hello?
Yes, ma'am.
Yes, ma'am. Ma'am, can
Yes,
you
ma'am.
explain me what about primary standard one time?
प्राइमरी स्टैंड आप बेटा आप क्लास से अटेंड नहीं किया क्या?
Sorry, ma'am, क्या था but थोड़ा सा confusion था.
Primary standard is a substance, okay, which has certain criteria. Like, so it should have a sufficient higher molecular weight. Okay, and also it should not react with atmospheric reactions like absorption of moisture and all these things. It should not undergo, and purity should be highly pure, ultra pure. Okay, and storing the primary standard at you should able to store the primary standard substance for a long period. Okay, these are all the main criteria. The substances who follow this criteria are called primary standard substances. Example for primary standard substances,
Okay,
of
ma'am.
course,
Thank you.
crystalline oxalic acid and silver nitrate and this more salt and all these things. Okay. So these reactions are limited to those involving, especially the precipitation titrations mostly involved with silver nitrate. Okay, wherever you are doing silver nitrate, okay, those type of titrations are called argentometric titrations, right? Argentometric means what? Wherever you are using silver nitrate in the titration, those type of titrations are called argentometric titrations. Okay, the precipitation occurs only when ionic product exceeds the solubility product. This concept, I hope all of you know it. Okay, when ionic product exceeds the solubility product only, the precipitation can take place. Okay, this is a major criteria for the precipitation titration. So precipitate formed must be practically insoluble. Okay, it should be insoluble. Precipitate formation should be rapid. Very fast precipitation formation should be there. The equivalence point should be easily detectable. You should detect the equivalence point. There are many precipitation methods. One is a Morse method, Volhard's method, and Fajon's method. These three are different precipitation methods. Okay. Let us come for the Morse method. So far it is fine. You understood what is argentometric titrations, precipitation titration, basic principle. Better?
Yes, ma'am.
Yes, ma'am.
Okay. Now we are coming to the Morse method. Okay, the Morse method is for determination of halide or chloride. For example, chloride. Okay, halide means bromide, chloride, fluoride. Okay, this is especially for the chloride with silver nitrate. Okay, silver nitrate using potassium chromate solution as the indicator. Here the indicator is potassium chromate. What you are going to determine? Determination of halide. Okay, for example, chloride. Fine. It is especially useful for the determination of chloride. Precipitated silver chromate. For example, what will happen if you are taking silver nitrate in the burette and potassium and in the conical flask chloride solution along with the potassium chromate. Okay, you are mixing the silver nitrate with chloride solution containing potassium chromate indicator. See, when you are adding dropwise, there will be the formation of silver chloride, the precipitation. Okay. At the equivalence point, completely the chloride ions will be precipitated as silver chloride. Okay. After the end point, equivalence point, whatever you add, extra drop of silver nitrate will react with potassium chromate and silver chromate will form. Okay. This silver chromate is red in color, whereas silver chloride is white in color. So at the end point, your coating, red color precipitate, coating of the red color precipitate will be visible onto the particles. Okay. It is especially useful for the this titration is as I told you, it is an estimation of chloride ions. Precipitated silver chromate through the sparingly soluble in water is more soluble than the, see, another question here, this point, this third point, third bullet, what it says is, even though potassium chromate you have in your conical flask, why it is precipitating later? Okay, the concept here is due to the, whenever the ionic product exceeds only, the precipitation will take place. Okay, before the end point. This is not stable. The silver chromate will form, but it's not stable. It will dissolve because ionic product doesn't exceed the solubility product. It exceeds only after the equivalence point. Got it? The third point is clear for you? Hello?
Yes,
Hello?
Yes, ma'am.
Yes, ma'am.
Then the sensitivity of the indicator depends on concentration, temperature, H+ ion concentration, the concentration of the electrolyte, and manner of absorbing red coloration. Sensitivity of the indicator. These are all depending on sensitivity of the indicator depends on these things. Concentration, especially. The concentration matters a lot. Then only when ionic product exceeds the only solubility product, then only the precipitation can take place. Okay. So these are all the sensitivity of the indicator. The last point. Okay. For example, the chromate formation, this is how at end point, this is how the reaction will take place. This is red in color. This will coat onto the white color silver chloride precipitate. So you can visualize the end point. Okay. So what are the precautions you can take place? So for this titration to occur, the medium should be neutral. The pH should be at neutral. The alkaline solution, what will happen in the alkaline side, alkaline pH? Silver will react with hydroxide and silver hydroxide will form. In acidic solution, chromate will be converted to dichromate. Okay, these are all known reactions. These two things will interfere. So you have to conduct the experiment only at the neutral pH. Okay, this is essential precaution for the experiment. Fine. Beta.
yes, ma'am.
Okay. The second method, Volhard method. Okay, this determines silver ions. Okay. So in earlier case, we have determined chloride ions. Here the silver ions will be determined. In dilute acid solutions, by titrating against a standard thiocyanate solution. What is the standard thiocyanate? The sodium thiocyanate is used. Okay, that is thiocyanate solution in the presence of ferric salt. Okay, ferric salt, ferric ammonium sulfate as an indicator. Okay, here ferric salt is an indicator. So ammonium or potassium thiocyanate solution is used here in silver nitrate. Here nothing but the silver ions are estimated. In general, silver ions will be taken into the conical flask, since this is the analyte here, and you will be taking the
तो पागल हो गए क्या? तुम सबको मेरे से क्या दिक्कत है? अपना काम कर लो ना.
What happened?
अरे बेटा माइक को बंद करो. Okay. So what is happening here? Volhard's method. Estimation of silver ions. Okay. So silver ions, here the ferric salt is an indicator. Okay. This thiocyanate solution is a standard. This will be taken in the burette. In general, we take standard solution in the burette. Okay. This is in the conical flask. Ferric salt is an indicator mixed with this. Okay. So when you have dropwise you add, silver thiocyanate will be formed. Okay. So this is grayish in color. Okay. At the equivalence point, when the reaction completes, when you add extra drop of standard thiocyanate, what is happening? The ferric thiocyanate, the salt, the ferric thiocyanate will be formed onto the, it will coat onto the precipitate of silver thiocyanate. So that is the red in color. So the reaction will take place like this. Okay, the ferric will converted into the ferrous. Okay. Sorry, this is 1 minute. Ferric salt, no? Ferric salt. Okay, yeah. The ferric thiocyanate will form. So you are taking silver nitrate. Okay, the silver nitrate when it reacts with the thiocyanate. Okay, so silver thiocyanate precipitation will take place, and at the equivalence point, what will happen? The indicator used is here. Okay, the ferric salt. The ferric salt will form this, and it will coat onto this precipitate. That is your end point. Okay, so in general, it has been done as a back titration. What is that back titration? The back titration is the so the back titration, you use the excess amount of one reagent. Okay, the remaining will be detected. The remaining solution will be determined. That is called back titration. Okay, so here if you see this, excess of sodium nitrate, silver nitrate is used with ammonium chloride. They are precipitating. This is known amount you are going to take, and you are precipitating the silver chloride. Remaining excess of the silver nitrate, remaining silver nitrate will be titrated against this. Okay, ammonium thiocyanate, and you will be getting the same. Okay, this is same. Nothing but the back titration means this you will use excess amount, and this is to avoid some interference of this. 1 minute. Interference of this chloride ions. Okay, that's why we do they do the things like this, because the water also contains a chloride ion. Okay, so this red color will be coated onto the white color of silver chloride. So this is how the titration takes place. So better this follow. You follow this Wohlhart's method. Hello.
Yes, ma'am.
One minute. Okay, so Wohlhart's method is over. Then coming to the Fajon method. Okay, the Fajon method, adsorption indicator is used. Okay, so what is that here? The see, action of this indicator is based on the simple fact the endpoint, the indicator should change the color. The adsorption indicator means the indicator is adsorbed on the surface of the precipitate. Okay, here the indicator is like fluorescent indicator. This is adsorption indicator. So how it is getting adsorbed, I am going to show you now. Okay, different slide in Fajon's method. One minute. So can you see this diagrams better? So
Yes,
initially what you are going to do is we are titrating silver nitrate with sodium chloride. Okay, what will happen? Silver chloride precipitation will take place. Okay, so as soon as you titrate, remaining is the chloride ions. Okay, the chloride ions will be adsorbed onto the silver chloride precipitate. Okay, the layer by layer formation will take place. Okay, as soon as you titrate silver nitrate with sodium chloride, silver chloride precipitation takes place. Okay, on to this is the first drop. When you add, silver chloride is formed. Okay, this is a colloidal precipitate. On the surface of this colloidal precipitate, the chloride ions will be absorbed as a first layer. Then the second layer will form with the sodium ions. Okay, this is how the layer by layer adsorption is taking place during the titration. That is before the equivalence point. Okay.
Ma'am, your
So,
voice is lagging.
yeah. So before the equivalence point, अभी ठीक है? Hello. Hello.
ठीक है मैम
Yes, ma'am.
Yes,
ठीक.
ma'am. अब ठीक है.
ठीक है मैम
It's
ठीक है
all right.
So before the equivalence point, what is happening? As soon as you add dropwise, the silver chloride will form onto the surface of silver chloride, chloride ions as a first layer. The second layer is sodium ions. Okay. So at the equivalence point, what will happen? The chloride ions will be reduced because silver nitrate you are taking in the burette and sodium chloride you are taking in the conical flask. Okay, so obviously the concentration of sodium chloride will reduce near to the equivalence point. Okay, so what will happen at the time? Your first layer will be displaced by silver ions. Okay, after that second layer will form nitrate ions. Okay, at the end point, when you add extra drop of the silver nitrate, what will happen? This nitrate ions, okay, will be displaced by your indicator. Okay, this is a fluorescent indicator. Okay, now obviously the color will change. The fluorescence coating will take place onto the silver chloride particles. Okay, this is what it happens in the Fajon's method. So do you understand this? Hello.
Yes, ma'am.
Peter,
Yes, ma'am.
यस मैम यस मैम
who is that late entry? अभी वो नहीं है इधर. So, so this is how the Fajon's method is. The explanation is here. Okay, you can understand. One minute, I'll go back. Okay, the Fajon's method happens like that. This is the Fajon's method. 1 minute again. Okay. So at the end point, what will happen? This fluorescent indicator, that a fluorescent indicator will form a reddish color, that a fluorescent color on the silver chloride precipitate. Okay, these are all the explanation given here. Okay, you can understand. I will also post my drawing. Along with that, if you read, you will understand. Okay, especially Fajon's method importance. What is the importance of Fajon's method? Because see, color detection is not so easy in the case of the precipitation titration. Okay, that's why the fluorescent indicator, if you use, the color will be intensive at the end point. You cannot cause any error in the titration. Okay.
Okay, ma'am.
So this intense color gives the end point of the titration. That is a way. So these are all the things. Here, if you see that next, I have given some numericals here. Okay. So numericals already posted. I want you to go through all these numericals. Beta, numericals are very important. Today you have to go through the numericals. Today evening I am posting 5 numericals. Okay. So 5 numericals you should work. Either tonight you should work it. Tomorrow's class we will be discussing those 5 numericals along with this numericals. Fine. Your exam will have a numericals also. So is there any other doubt you people have?
मैम एग्जाम में कितने नंबर का होगा?
15. 15 marks, 6 questions. Within 1 hour you have to answer. You should write in the A4 sheet and scan it. You should upload as a single PDF file. Is there any doubt here? You should have a software, you know that the the scanning software is there. So you should use that, the Adobe Scan. समझ गए बेटा?
Yes, ma'am.
Yes, ma'am.
So Ishang, you should brief them. If anyone don't know how to use Adobe Scan, you should brief them. This is a responsibility of the class representative.
और मैम सिलेबस आज का नहीं आएगा ना?
आज का जरूरी आ जाएगी. मैंने बोल चुका ना. Whatever I teach up to Wednesday, that is complete. I am completing everything. All the trigonometric analysis got completed. Okay, so numericals will be discussed tomorrow. सब आ जाएगी. Already I told you. Okay.
Okay, ma'am.
Okay. So let me explain. If I have a slides, I will explain the this. I will also post you the this. Dissolved oxygen and dissolved chlorine, which one has been done in your practicals? Hello? Dissolved oxygen हुआ and dissolved chlorine हुआ. What is that?
Dissolved oxygen. Dissolved oxygen.
Okay. This also I will explain tomorrow. Okay, the reactions involved in dissolved oxygen and dissolved chlorine. Okay, definitely the numericals you have to. Today I will leave you before 10 or 15 minutes. You should practice this numerical. That is very essential. Okay, so 5 numericals I will be posting now. Okay, then you practice that. Tomorrow's class. Tomorrow what time is your class? 3 to 4, na? Hello.
Yes, ma'am. Yes, ma'am.
Yeah, during that time we will be discussing the numericals, and Thursday I will give the question paper. I'll post the question paper exactly before, just 5 minutes before the class, and you should start working on it. Prepare for the exam. That is more important. Okay. See that three class tests will be conducted in January, February, March. Okay, out of these 3 class tests, 2 best tests will be considered. Okay, so MTE component beta, is there any doubt on MTE component? कुछ सोचा और क्या किया?
मैडम उसमें कोई टॉपिक लेके उस पे मतलब बस रिसर्च करनी है ना थोड़ी, मतलब कुछ पेजेस
थोड़ा रिसर्च मतलब थोड़ा इनोवेशन होना है. Innovation होना है. Either, for example, green chemistry. Okay. Green chemistry के ऊपर थोड़ा general points apart from outside of your syllabus. Okay. We teach principles of green chemistry. Okay. You can think of a small reaction. How is it a green reaction? Like that you can explain.
Okay.
Okay, or some people who are interested in coding. Okay, so some small numerical you can take and write the program.
Coding में कितने numerical?
Coding मतलब writing the programs, computer program.
वो तो पता है, मतलब प्रोजेक्ट कितना पेज का होना चाहिए कोड के लिए? कोड तो छोटा सा हो जाता है ना फिर.
Yeah, that innovative things you have to choose. You have to choose according to that. Okay. For example, there are many things. Other unit, if you see the thermal analysis. Okay. So data, you can convert the temperature difference into the enthalpy. There is another thermodynamic parameter called enthalpy change. Okay, how to convert temperature difference to enthalpy change. Okay, or Cp, that is Cp, the heat capacity at constant pressure. Okay, so I will be explaining all these things. You can write programs for all these things. And based on this, Viva will be conducted. You have to perform very well in your Viva. Okay, in this, out of 75, 76 students are there, you pair up yourself. Two people should choose one project. Okay.
ओके मैडम. मैडम एटलीस्ट कितने न्यूमेरिकल होने चाहिए अगर कोडिंग कर रहे हैं तो?
कोडिंग कर देते हो तो 5 न्यूमेरिकल्स करो.
ओके मैडम.
Okay, so Ishank.
Yes,
Hello.
ma'am.
Okay, you should give me the topic and the group, and as early as possible by Friday.
Okay, ma'am.
Okay, then the proposal should be submitted. I have to conduct the first evaluation also. Okay, beta.
Yes,
So
ma'am.
the test is on Thursday. The complete topic is coming. If anyone has any doubt in this particular unit 1, and you please respond to me now. I am ready to solve your doubt. बेटा कुछ डाउट है?
Ma'am, Viva will be on the basis of a project or syllabus?
Yes, on the project, how you have done the project. Some people they will simply copy, okay, or internet se copy करके ले सकता. You have to make 5 slides out of your project. Okay, the 5 slides you have to explain whatever you are writing in the slide. You should give explanation for me. You cannot copy as such. There should be some originality in your slide. Got it?
टॉपिक कौन सी चूज करें?
हेलो
मैम टॉपिक कौन सी चूज कर लें इसमें?
Topic, that is your freedom. Connected to the syllabus, you have the syllabus. The 5 topics are there, like titrimetric analysis, thermal analysis, spectroscopy. Spectroscopy is again a vast topic. There also some interesting things are there. You can choose that also, like structural elucidation and all these things. Apart from spectroscopy, the phase rule is there, and polymer science is also a small topic is there, and green chemistry, electrochemistry. Out of this, you can choose any topic and make your innovative idea. Got it? Roll number 45.
Yeah, ma'am. Yeah. Okay. Thank you.
Yeah. Anybody else has any doubt?
मैम यूनिट 1 में जो कर्व वाला क्वेश्चन था ना, कर्व वाला, वो समझ नहीं आया था. उसमें आवाज की प्रॉब्लम थी आपकी.
Yes, I am coming now. This acidimetry and alkalimetry. This? Hey, beta.
Yes, ma'am.
Okay. See, here you are titrating strong acid versus strong base. Okay. You are titrating, you are taking in the conical flask the strong base. Okay. Adding strong acid. What will happen when your conical flask solution is a base, your pH is around 14. Right? When you dropwise we mix the acid, what will happen? It will keep on neutralizing at one point. That is the equivalence point. This is the beginning of this curve. It's called the equivalence point. Okay. When you add extra drop of acid, suddenly the pH will dump to the acidic pH. Okay. This portion shows the sudden jump. Okay. The mid of this one is the at mid of this sudden jump is the pH 7. Okay, that is that shows the complete neutralization has taken place at at the equivalence point. So when after this that it will become acidic, and this is the end point. Okay, so this to this is the complete that is pH 4 to 10. There will be a sudden jump. Okay, so this will help us, this portion will help us to decide on your indicator. So since this change is taking place from pH 10 to 4, so according to this range, you have to choose the indicator, whether the phenolphthalein or methyl red or methyl orange. This sudden jump shows that this, if you see here, this is a 4. Okay, the 4, if you speak 4, and only the methyl orange can be used for strong acid and strong base. This, especially this potentiometric titrations, this is actually the potentiometric titration curve. Okay, so this is helpful to choose an indicator. This is how the indicators are chosen. Samajh gaye?
Okay.
Okay, so when you take the weak acid, strong base, what will happen? The weak acid always equilibrium hota hai, like acetic acid. If you take acetic acid, and always the equilibrium hota hai, dissociation. So this portion will be short, okay, because of that. Okay, so this is the portion where the sudden jump is taking place, that is pH range 7 to 11 will happen. Okay, this vertical portion. So the color changing portion here, the pH 7, okay, the end. Okay, so what is the suitable indicator? The suitable indicator is phenolphthalein, because it is changes the color from the range of 8 to 10. This is especially this type of experiment, so to choose the suitable indicators. Fine. Again, if you see this, the strong acid and weak base, this again, this portion is different. That is the 4 to 7. Okay, so 4 to 7, again, the methyl orange is an indicator for this type of, especially this type of titration. Strong acid, that is hydrochloric acid, versus that is ammonium hydroxide. Ammonium hydroxide is a weak base. The dissociation is very difficult here. Okay, when you come weak acid and weak base, here dissociation is very, very difficult. This also equilibrium is there, for this also equilibrium is there. The sudden jump, it may not take place. This curve is like a wavy curve. Okay, so there won't be any short change here. That's why this type of titration by titrimetric analysis is very difficult. You cannot do it. Okay, so, and also the end point is not sharp here. So it is very difficult to choose a suitable indicator for this type of titration. Samajh gaye?
Yes, ma'am.
Yeah. So is there anyone has any other doubt? Beta?
No,
So,
ma'am.
yes, please. Okay. So listen, today you please, look for the numericals, solved numericals, whatever I posted. Okay, this is there at the end of your PPT. Okay. So, and then carefully you work on the 5 problems, whatever I'm going to post. And tomorrow, 3 to 4 your class, during that time, I'm going to discuss. Okay, that is numericals are very important in this unit. Okay. Ishaq, yes, please. Yes.
Ma'am, the process of making methamphetamine हो सकता है topic.
What is it? You please be, you repeat. Please repeat, beta.
Ma'am, methamphetamine का process.
Process for what you, okay, green process, the green method, green synthesis you can make, you can suggest anything.
Ma'am, how to cook methamphetamine?
Ma'am, how to cook methamphetamine?
Yeah, what is this word methamphetamines?
मैं टाइप कर देता हूँ.
टाइप करो. तो okay, yeah, ठीक है. Yeah, you should, yeah, you can
Yes, ma'am.
you can find the separate green process for this.
Green process.
Green process means, see, there are some of the, see, nowadays organic solvents are very harmful to use for synthesizing some of the compounds. Okay, now they are replacing with the green solvents. Okay, there are many green solvents. You can discuss about it, whether it is possible to do the synthesis using the green solvent. You can describe the process. Got it? Beta. Or green battery. The battery is also a topic. Now the solar energy is very much encouraged to be used. You can talk about the solar energy also, solar batteries.
Okay, ma'am. Thank you.
Got it? There are many easy things. You should sit and think. You should give some time to think. Don't take some complicated thing. You take a simple thing, make 5 PPTs. You should explain the 5 PPTs, whatever you are presenting. There should be some originality in that. It should not be a copy exactly from the internet. Okay? So here, if you see that 20 marks are